Hello and welcome back to CERN. You know, the ATLAS experiment is one of the largest and most complex scientific instruments ever constructed by mankind. It's now been assembled and is waiting for collisions at very high energies, higher than anything we've ever done before. So what's going to happen when we go to these high energies? Is the experiment ready? Is the collaboration ready? What are we going to find? Let's go talk to our spokesperson, Fabiola, and find out. So in the collaboration, you have representatives from countries all around the world. How many are there? How many institutes, how many countries?
So we have almost 3,000 scientists working in ATLAS, coming from 172 institutions from 39 countries and 5 continents. So it's really a worldwide collaboration.
It's everyone.
Yes, it's everyone, yes.
You mentioned that it's a very large, or the largest of the experiments. How big is ATLAS?
ATLAS is really a big instrument. It's 45 meter long, 25 meter high, so almost a 5-story building. It's made of 100 million electronic channels, individual electronic channels, each one giving signals when particles cross the detectors. And so we have to collect those signals, and we need 3,000 kilometers of cable to extract those signals from the detector and collect them and then record on mass storage. So it's really a big monster.
I know we're going to have high energy collisions very soon. What will happen?
So the LHC is now going to open the door to an unknown territory, because nobody has ever explored the 7 TeV region. The collisions that the LHC will provide soon are going to be 3.5 times higher energy than the most powerful accelerator today on Earth. Will
ATLAS itself have to make a lot of changes to be ready for this stage?
No, I don't think so. I think we are all set. We are ready to record collisions. We also the rest of the experiment, not only the detector but also the software tools, the computing, worldwide computing grid is ready, and so we are just impatient.
At these higher energies, higher than we've ever had before, we hope to find new discoveries. What could be some of the early discoveries we might see?
Yeah, I can speculate within the scenarios that have been developed by us, by physicists, by theorists over the last years. So, for instance, we could discover supersymmetry. Supersymmetry is a theory beyond what we know today, which predicts a new spectrum of particles, and this will be particularly nice because one of these particles, called the neutralino, has exactly the features and the properties that of the mysterious particles that makes up dark matter in the universe. But there are other scenarios, the possibility of discovering new forces, the possibility of discovering new space dimensions. Of course, all of them are very intriguing. However, I must say that nature is always more clever and more interesting than all our speculations. So I really do hope we can find something new and unpredicted.
Now, there's a lot of talk about the Higgs as an important particle to discover, something that's missing from our current puzzle. When will we find that?
The Higgs will require some more time. You know, it will require a lot of solid experimental work, first of all, to understand very well the detector performance, to measure all these backgrounds before we are able to claim a discovery. And this will require a lot of data. So the Higgs is not for tomorrow.
No. Few years, maybe?
Few years, maybe.
In a few years' time.
Yes.
So it seems that one way or the other, we're going to find something that's very important for us physicists to understand the composition of matter. How is this important in the big picture? How will this affect us, people back at home?
I think that many of the discoveries that we are hopefully going to do at the LHC are so important from the fundamental knowledge viewpoint, that everybody should feel concerned. Besides that, we never know what the consequences of these discoveries are. Every single step forward in fundamental knowledge is a step forward in progress. And of course, it's very difficult to predict the consequences also in a practical life beyond fundamental knowledge, but we can be sure that there will be positive consequences for all of us.
So ATLAS is about to visit the unknown. Some of the particles that we expect to find, we might in the next couple years, such as supersymmetry. Other things like the Higgs that might take a bit longer. Fabiola has told us that she's hoping we find something we never expected before. I hope she's right. One thing's for sure, whatever we do find, mankind will absolutely benefit from having a better understanding of the world around her. Atlas is ready to go.